Greetings, detectives. Mrs. McKay here, and this is Clue 2 for Case 4 sequence scenarios. And our clue, learning target clue, is I can identify the common difference So you're going to write the word difference. I can identify the common difference in an arithmetic. I can identify the common difference in an arithmetic sequence and the common ratio in a geometric sequence. So make sure that you have that written down. I can identify the common difference in an arithmetic sequence and the common ratio in a geometric sequence. That's our clue, and that's what we'll be doing today. Before we do that, let's do a quick review. Let's remember what a sequence is. A sequence is a list of terms, can be numbers, can be shapes, figures, but it has a pattern. So it is a series or a list So a series of terms with a pattern. And an example of an arithmetic sequence, the changes from one term to the other is that we add the same thing. So an example of an arithmetic sequence would be 4, 7, 10, 13, and so on. And I keep adding 3 to the next term to get to the previous term to get to the next term. And then a geometric sequence is also a list of numbers, but instead of adding something, I'm multiplying something. So I could go with 5, 25, 125. You see it? 5, 25, 125. I'm multiplying each one by 5. So that's what my geometric sequence would be. I'm multiplying by the same thing. Why don't you go ahead and tell me what the next term would be after 125? The last thing that I want to review is just the meaning of term. So if I have this sequence, what is the third term of the sequence? The third term. Well, the third term is the 1, 2, 3, the third member of the sequence, okay? So that a term just means the member of the sequence. And so when we're actually looking at sequences and we're talking about terms, we sometimes write them like this: term, and then value. So we would write term 1 is 2, term 2 is 4, term 3 is 6, term 4 is 8, just so that you can see how we can recognize it. All right, so now let's talk a little bit more specifically about arithmetic and geometric differences. Now, we've already noticed that there's something common about them, that there's this constant thing that happens. With an arithmetic sequence, we are constantly adding the same number. It could be a positive number or it could be a negative number, but from one term to the next term, there's always the adding of the same number. So we call that a common difference. It's called a common difference. So right here, common difference. That is what makes an arithmetic sequence an arithmetic sequence. So let's look at some sequences that I have written down here. I have 1, 2, 3, 4. Can you tell me what am I doing from 1 to 2? And then what do I do that's the same thing from 2 to 3 and from 3 to 4? Well, you can see that I'm adding 1 each time, aren't I? So my common difference is 1. Okay? I'm adding 1. Go ahead and tell me what the next two terms of this sequence would be. 1, 2, 3, 4. What would the next two terms be? That's right. 5 and 6, right? All right, let's do the next one. 3, 6, 9, 12. What's my common difference? Can you figure it out? What do I do between 3 and 6 that's the same thing between 6 and 9? Well, you're right. I'm adding 3. From 3 to 6, I add 3 to 3 to get 6. I add 3 to 6 to get 9. And 3 to 9 to get 12. So my common difference is 3. And what are my next two terms? Go ahead and write them in. My next two terms are 15 and 18. Yes? All right, let's do the next one. 100, 50, 0, negative 50. What am I doing? What is my common difference? What am I doing between 100 to 50, and then from 50 to 0, and 0 to negative 50? I'm subtracting 50, aren't I? So I'm adding negative 50. So my common difference is negative 50. Now you go ahead and tell me what the next two terms would be. Well, if I subtract 50 from negative 50, I get negative 100. And if I take another 50 away from that, adding negative 50 to negative 100, I get negative 150. All right, next one. 1, 0.5, 0, negative 0.5, negative 1. What am I doing? What am I doing? Well, from 1 to 0.5, I actually subtracted 0.5, didn't I? And then from 0.5 to 0, I subtracted or added another 0.5. And from 0 to negative 0.5, again, negative 0.5. And from negative 0.5 to negative 1, another negative 0.5. So my common difference is negative 0.5. And what would be my next two terms? Go ahead and write those in. Did you come up with negative 1.5 and negative 2? Those are my next two terms. All right. That's arithmetic sequences. So the key thing to remember is that an arithmetic sequence is a series of numbers with a common difference that is a constant between each term. That's the key, is it has to be a constant, and it's the difference is being added. Okay, so it can either be positive or negative, but it's being added. All right. Okay, now let's talk about geometric sequences. Geometric sequences have a common ratio. Common ratio. And a ratio is talking about how things are multiplied or divided. If you remember back in your pre-algebra days, you saw ratios look like this. A ratio would be 3 to 4. That's a ratio. But it's also a division problem, 3 divided by 4, isn't it? So what we're doing when we find a common ratio is we're looking to see, what do I have to do from one term to the next term? What do I do? Well, I'm multiplying by something, aren't I? I'm multiplying by something. So to get from 2 to 4, I could have added 2, but I always have to look at my next term. Which is another 6, which I went from 4 to 6, and then from 6 to 8. So is this an arithmetic sequence or an geometric sequence? It's underneath geometric sequences, but it's actually an arithmetic sequence, because from 2 to 4, I add 2. From 4 to 6, I add 2. From 6 to 8, I add 2, don't I? So this is actually a geometric sequence, and it needs to go up here, right? So we'll write 2, 4, 6, 8, put my little squiggles, and my common difference is 2, and the next two terms would be 10 and 12. So this doesn't even belong here, does it? So let's do the next one instead. 2, 6, 18, 54. So what am I doing? What's my common ratio? What am I multiplying 2 by to get 6? And then 6 by to get 18, and 18 by to get 54. Can you figure it out? Well, I'm multiplying by 3. And from 6 to 18, I'm multiplying by 3. And from 18 to 54, I'm multiplying by 3. So my common ratio is 3, because I'm multiplying by a number. Now you go ahead and figure out what the next two terms are. Feel free to use your calculator. I'm going to. So 54 times 3 is 162, and 162 times 3 is 486. All right, let's do the next one. 100 to 20 to 5 to 1, which that isn't quite right. So we'll have to figure it out. From 100 to 20, I should have divided by 5. Do you see that? I divided by 5. And then from 20 to 5, if I was going to divide by 5, this should have been not 5, but 4. Looks like I'm having trouble. So change that 5 to a 4. And then the 4 divided by 5, or multiplied by 1/5, should have been 4/5. So looks like from 20 to 5, I divided by 4 instead of by 5. So I was creating these notes too quickly. So my common ratio is to divide by 5 or to multiply by 1/5. Multiply by 1/5. So that's what my common ratio is. We always talk about what we're multiplying by. And then my next two terms would be 4/5 times 1/5. So what's 4/5 times 1/5? 4/25. And my second term would be 4/25 times 1/5, which would be 4 over 125. And those are my next two terms. All right, let's see if I did this next one right, because this one's a little bit trickier down here. Take a look at this one. 1, -4, 16, -64. What is my common ratio? What am I multiplying each number by to get the next term? Well, I multiplied 1 times 4. You might have thought that this was times 4. But 1 times 4 doesn't give me -4. It gives me 4. So maybe it's 1 times -4. So 1 times -4. Then if I take -4 and I multiply it by -4, am I going to get a positive 16 or a negative 16? That's right, I get a positive 16. So -4 times -4 is positive 16. And then 16 times -4 gives me a -64. So my common ratio is -4. And what do you notice? It keeps going back and forth, doesn't it? Between positive and negative, positive and negative. So let's go ahead and do our next two terms. So when I multiplied -64 times -4, I got a positive 256. And then when I multiplied 256 times a -4, which is my constant common ratio, then my calculator told me that it was